Hello dear students, welcome to the e-classes organized by Purna Chandra Higher Secondary School, Raghunathpur, Baripada, Mayurbhanj. For more information about the college, you can contact the details provided on your screen. Thank you. So my dear students, in our last video we have discussed about what is a compound microscope. Okay, so now we are going to discuss the next optical instrument, that is what is a telescope. Okay, so you all listen the word what is a telescope in your childhood days. You want to see the distant object, so your parents bought you a telescope. Okay, so you all are familiar about the word telescope. So here we are going to discuss about what is a telescope and how it works. Okay, so dear students, so what is a telescope? So telescope enables us to see the distant object clearly. It means the planets, the stars, okay, the asteroids, the comets, which are known as heavenly bodies, okay, that are very far away from us. So we use a telescope in order to see these types of heavenly bodies. Okay, so telescope usually used to see the things clearly which are far away from our vision. Okay, so here I have written the telescope helps us to see the distance object clearly. But my point. So now let's discuss about the basic concept of a telescope. So here I have drawn a figure of a telescope. So look at this figure. So this is a figure of a telescope. Okay, so this is a tube. Okay, these are two metal tubes, and on the one metal tube a large lens, convex lens. Okay, a large convex lens here is fitted, another lens here is fitted. Okay, so these two are fixed into a tube, and there is an adjustment so that this tube can move inside the large tube. Okay, there is an adjustment called rack and pinion adjustment. Okay, what? Rack and pinion adjustment. By using this rack and pinion adjustment, you can move the small metal tube inside the large tube so that you can fix the focal length in between them. Okay, so this is a basic figure of a telescope. Here I have placed my eye. Okay, so the lens close to eye is known as eyepiece. Here this lens is close to the object. Okay, so this is known as objective. It is objective and this is known as eyepiece. So dear students, telescope are of two types. Okay, telescope are of two types. What my point? Telescope are of two types. So first one is refracting type. Okay, which type? Refracting type, and second one is reflecting type. What? Reflecting type. One is refracting type and another one is refracting, another one is reflecting type. Refracting type telescope means in this type of telescope the laws of refraction, or I can say refraction happens in that type of telescope, and in reflecting type telescope here reflection happens. And refracting type telescope are of two types. But my point, remember these things. Refracting type telescope are of two types. First one is astronomical telescope. What? Astronomical telescope, and another one is terrestrial telescope. What? Astronomical telescope and terrestrial telescope. Astronomical telescope means what? It is used to see the heavenly bodies, okay, like the stars, the moons, the planets. These are the things which can be used to see astronomical telescope in order to see these things. And another one is terrestrial telescope. Terrestrial means the objects on the land. Okay, something on the land. Suppose I am standing here, I want to see the Similipad hill. Okay, so here you use terrestrial telescope. Okay, something on the land but that are far away from us. Or I can say we use binocular. This is a kind of terrestrial telescope. In binocular, we usually binocular is used to see the distance objects that are present on the land. So this is a type of telescope. So refracting type telescope है, astronomical telescope and terrestrial telescope. And the example of reflecting type telescope is Newtonian telescope. Okay, but Newtonian telescope and Cassegrain telescope. Okay, first one is Newtonian telescope and another one is Cassegrain telescope. These are the example of reflecting type telescope. Okay, dear students. But here our study is not to individually study astronomical telescope or terrestrial telescope or this type of telescope. We are just here will study the basic principle of a telescope and how it works and what is its magnification. We just here to study the basic principle of a telescope, how it works. Okay, so dear students, we are going to discuss about fast refracting type telescope, that is astronomical telescope. Okay, so note these things. So first one, that is astronomical telescope. Astronomical telescope. Let's discuss about astronomical telescope. So dear students, like a simple microscope and compound microscope, we know that the range of human vision is from to d distance to infinite, or I can say from infinity to d. So here we have to discuss that two cases, that is where image is formed at infinite and where image is formed at d distance. Okay, so first we are going to discuss about first as image formed at infinite. Okay, so let's discuss about when image is formed at infinite, or it is known as normal adjustment. Okay, so this case is known as normal adjustment. But my point, image formed at infinite, it is the case of normal adjustment. So here I have drawn the ray diagram of a telescope and normal adjustment. We will discuss further about the ray diagram. Now there are few important points that you have to know. So first one is, you know that the telescope are usually very small. Okay, astronomical telescope are usually, astronomical type telescope is a refracting type telescope and these are smaller in size. So dear students, this is the eyepiece and this is the objective and this is that one the eyepiece. So they are very close to each other because they are fitted in a certain tube and they are very close to each other in respect of the distance of the object from the telescope. It means usually astronomical telescope is used to see the planets, the stars, so that the distance between the stars to the lens is very large than that of the length between the two. Okay, it means the length between the two lens is very less than that of the length between the telescope and the object at infinite. Okay, we usually consider the planet, the stars are at infinite, so the distance of the telescope from the object is very large than that of the distance between the two lenses. So dear students, we can, due to the distance, we can take the light coming and making an angle at the objective is same as that of the objective is same as that of the eyepiece. Listen carefully. As the distance between the telescope and the object is very large, the ray coming from the infinite and making an angle at objective at eyepiece and our eye is nearly taken as same. Okay, I am going to elaborate these things that where object is at infinite, the ray of light coming from infinite, it makes same angle at the objective, at the eyepiece as well as on the eye. Okay. So here now discuss about when image is formed at infinite. So first let's discuss the ray diagram. So the students look that this is objective and this is eyepiece. Okay. So in telescope this objective has large aperture, I can say large in size and have large focal length, and eyepiece is small aperture and small focal length. Again I am telling objective is large aperture and having large focal length, and eyepiece has short aperture and short focal length. So now you usually take the parallel rays of light. Okay, if these are the two lenses, they are coaxially fitted, or I can say this line is the principal axis. You usually take the ray of light that are parallel to principal axis. Okay, so that after refraction they will focus, they will meet at the focus. It usually happens, but in this case, intentionally I have taken parallel rays of light, but not parallel to the principal axis. Okay, we have taken parallel rays of light, but not parallel to the principal axis. If we take the parallel ray of light, okay, they will meet at the focus, or I can say focus is on the principal axis, then it will be the image will be very small, or I can say it is like a point. So it is very difficult to magnify a point. So here intentionally I have taken parallel rays but not parallel to the principal axis, so that they after refraction, we know that parallel rays of light after refraction meet at the focus. So these two parallel rays of light after refraction meet at the focus. So this is the focal plane, but this is known as focal plane. So here in this case, these two ray of light, the ray of light are coming from infinite. So the ray of light after passing or refraction, they are meeting at the focus, but the image is formed at focal plane. It means if I take a sheet of paper and insert here, then this plane is known as focal plane, and image is formed on the focal plane. So a image of certain size, I have got certain size. Got my point? So this is the basic principle. An object is at infinite, ray of light coming, and after refraction they meet at a dash and an image a dash b dash of the object at infinite is formed. Okay, so now we know that we have rack and pinion adjustment. So that part we have done. As we have rack and pinion adjustment, we adjust the focus of the eyepiece in such a way that the image dash formed by the objective is on the focus of the eyepiece. It means the image dash is formed on the focus of the eyepiece. Got my point? So B dash is the point that is the focus of the objective as well as the focus of the eyepiece. It means this B dash point is FO, also FE, because this is the focal plane for objective. So this is the focus and FE. We adjust the focal length of eyepiece in such a way that the image dash B dash is placed or formed on the focus of the eyepiece. So a object placed on the focus, or I can say you know that when object is at focus, the image is formed at infinite. So a ray of light going like from a dash like this and enter to my eyes, another ray of light going like this. So these are parallel to each other, not going to meet in the forward direction. So I just backtrace the direction and form the image at infinite. Okay. Now the object is at infinite. Here you can write object at what? Object at infinite. Similarly, image also formed at what? Infinite. Now this is known as, this point is FO. The distance between C1 to FO is known as focal length of the objective. This distance between B dash and C2 is known as object distance, and this object distance for the eyepiece is the same as that of the focal length of the eyepiece. It means UE equals to F of E. Okay, so I think you got the ray diagram. So we intentionally take parallel rays not parallel to the principal axis because we have to form a image of certain size or certain height. So I have take that type of rays. Okay. So after refraction they meet at a dash, and this image form a dash b dash on the focus of the eyepiece. So and a dash b dash further act as an virtual object for the eyepiece and form an image at infinite. So now let's find the angular magnification. So you know that for angular magnification m equals to how much? Tan beta upon tan alpha. You know this, tan beta divided by tan of alpha. So now we have to find beta and alpha, or I can say alpha beta. You know that I have already told that the object is usually at infinite and the length of the telescope is very small when compared to the distance. So the angle formed at eyepiece, it is same as that of the objective is same as that of our eye. So I can take this angle as alpha. Okay, usually alpha is what? Alpha is the angle made at the eye. Here I have told the angle made at eye is same as that of angle made at objective. So if this angle is L, then these two lines are crossing each other. If this is alpha, then that is also alpha. Okay, and the image is formed like this at infinite, and a ray of light going like this and make an angle at our eye is what? The angle beta. So here I have found the angle alpha and beta. This is alpha. So this is alpha, and beta is what? The angle subtended by the image on our eye. So this ray makes an angle beta with our eye. So let's find tan alpha and tan beta. So now let's find what is tan alpha. So tan alpha is how much? P upon D. Now look the triangle. Look the triangle A dash B dash C1. Okay, triangle A dash B dash C1. In this triangle, tan alpha is what? Tan alpha is A dash B dash by B dash C1. A dash B dash by B dash C1. And now look the triangle A dash B dash C2. Triangle A dash B dash C2. In this triangle, tan beta is how much? Tan beta equals to A dash B dash upon B dash C2. Okay, we have found alpha and beta. Now put this in this equation. So m equals to what? Tan beta. Tan beta is what? A dash B dash by B dash C2. This is tan alpha divided by tan alpha is how much? A dash B dash by B dash C1. This is tan beta, this is tan alpha. Now solve this. We can found m equals to how much? A dash B dash by B dash C2 into B dash C1 by A dash B dash. Okay, if I solve, I will got this. A dash B dash and A dash B dash will cancel out each other. So we will find m equals to how much? B dash C1 by B dash C2. Okay, but B dash C1 by B dash C2. Now let's find what is B dash C1. B dash C1. This is FO. Okay, this is FO. So it is right to the left. So I can say it is close FO divided by B dash C2. B dash C2. It is FE. So and it is to the left. So I can write it with minus FE. So I found the magnification as M equals to what? M equals to minus FO upon FE. Okay, but M equals to minus FO upon FE. So this is the angular magnification of the telescope when the image is formed at infinite, or I can say at normal adjustment of the astronomical telescope, the magnification is minus FO upon FE. Okay. So this is the first adjustment, that is image formed at infinite. So there is another case, that is image is formed at distance d. Okay. Now let's discuss when image is formed at distance d. Now note these things. Okay. So this is the second case. Okay. So we have discussed that the image is formed at infinite, it means normal adjustment. Now we will discuss when image is formed at distance d. So d means what? 25 centimeter. It means the distance of the image from the eye is 25 centimeter. Now look at the ray diagram. Okay. So this is the objective having large aperture and large focal length, and this is eyepiece. Okay, this is having short aperture and short focal length. So now, as usual, we have taken the object at infinite and intentionally take such type of rays. Okay, so that it forms an image A dash B dash at the focal plane of the objective. It means A dash B dash. Okay, A dash B dash is formed at the focal plane of the objective. It means this is FO. But in a previous case, we discussed that the FO and FE, it means focus of the objective, and F of E, it means focus of the eyepiece is at same place. But here in this case, this is not happening. It means we have a rack and pinion adjustment, so that we adjust the eyepiece in such a way that the image A dash B dash is formed inside the focus of the eyepiece. Remember, this is the basic difference. In normal adjustment, FO and FE are at same place, but look that here in this case the FE, it means the focus of the eyepiece is here, but the image is formed inside the focus here. Okay, so FE to C2. FE to C2. This is known as focal length of what? Eyepiece. So this is known as FE. So this is FE. Okay. So I am again going to tell you that the image ADS is formed inside the focus of the eyepiece. But in previous case, the image is formed on the focus of the eyepiece, but here the image is found inside the focus of the eyepiece. So you know that when an object is inside the focal length, or I can say when object is placed between optical center and focus, the image is virtual and formed at the same side of the lens. So now look that, so this A dash B dash is the image formed by the objective, now behaves as a virtual object for the eyepiece. Okay, so now let's take two rays. One is going through this and another one is going like this. If I backtrace the path of light, they are meet at point A double dash, and this is B double dash. If you mark it A double dash, it will be B double dash. Now the final image A double dash B double dash is formed at a distance D from our eye. Got my point? Try to understand the ray diagram first clearly. So now this is the distance D, or I can say BE, image distance from the eyepiece. It is as D, and this is the focal length. This is FO and C1. This is FO means focal length of the objective. This is FE and C2. This is focal length of the eyepiece, and UE, it is the object distance of the eyepiece. B dash to C2. Now we have to find the angular magnification, that is m equals to tan beta upon tan alpha. Okay, so now let's find tan beta and alpha. As usual, if this is alpha, this is also alpha, and a double dash b double dash, a double dash b double dash is the image that makes an angle beta. Here, okay. So this angle is beta and this one is alpha. Now let's find what is tan alpha. What is tan alpha? Now look the triangle a dash b dash c1. Triangle a dash b dash c1. In this triangle, tan alpha is how much? Tan alpha is a dash b dash by b dash c1 at b dash c1 p by b. Similarly, now we have to find tan beta. Now take a dash b dash c2. Okay, so you can ask, sir, why you are not taking a double dash b double dash c2? Because if we take a dash b dash instead of a double dash b double dash, a dash b dash and here a dash b dash can be cancelled out. So I get this. So in triangle a dash b dash c2, tan beta is how much? Tan beta will be a double dash b double dash divided by b dash c2. Okay, this is the value of tan alpha and tan beta. Now put these things into this equation. Tan beta is a dash b dash by b dash c2 whole into b dash c1 by a dash b dash. This much. Put this value, it will be given like this. A dash b dash will cancel out. So we found m equals to b dash c1 by b dash c2. Okay, what is the value of b dash c1? B dash c1. Tell me what is the value of b dash c1? This is f o. Okay, so here you can write f of o divided by b dash c2. B dash c2. This is object distance of the eyepiece. This is ue. So f o upon ue. So we found m equals to what? M equals to f o upon ue. Okay, so this is the angular magnification, but here it is UE. I have already discussed that when the magnification is in terms of UV, always try to change it into the focal length. So if I write the length equation for eyepiece, okay, but length equation for eyepiece. If I write length equation for eyepiece, then it will be 1 by VE minus 1 by UE equals to 1 by FE. This is the length equation. From here you can write 1 upon UE equals to 1 upon VE minus 1 upon FE. Take this to right and take this to left. 1 by UE equals to that much. Okay. So, note these things. So we found m equals to f upon ue and we found 1 upon ue equals to 1 by ve minus 1 by fe. Now m equals to what we found? Fo into 1 by ue. This is, now put the value of 1 by ue. Okay, so m equals to Fo into 1 by ue has the value 1 by ve minus 1 upon fe. Here, this is the value of 1 by ue that I have inserted here. 1 by ve minus 1 upon fe. So here it gives m equals to, if I take 1 by fe common, so it will give Fo upon fe whole into Fe by Ve minus 1. Okay, take 1 by Fe as common. If it will be minus 1 and Fe will be multiplied here. So Fe by Ve minus 1. Now use sign convention. Okay. Now use the sign convention. We know Fo equals to how much? FO, right to the length, so it will be plus FO. FE, here FE will be what? FE. This FE, focal length is always positive, it will be plus FE. And what is VE? VE will be what? D, that is minus D. Left to the left, so it will be minus D. Now put these values in this equation. So M equals to FO upon FE whole into FE. It is plus FE by VE is minus D, minus 1. If you take minus, negative sign as common, it will be minus FO by FE 1 plus FE divided by D. Okay, now all are in the terms of focal length. So this is the angular magnification of the astronomical telescope when image is formed at distance d, that is minus FO by FE whole into 1 plus FE by D. So this is the angular magnification of astronomical telescope. So we have discussed all the concepts of astronomical telescope. So for any kind of doubt, ask me in the comment box. Thank you.